Welcome back. In this video, we're going to look at part B of this question, which asks us to find a basis for the vector space Q adjoin root 5 and root 11. And so in the previous video, we showed that the square root of 11 was not an element of Q adjoin root 5. And so what that tells us is that the list 1 square root of 11 is linearly independent over Q adjoin the square root of 5. Which means if we take some Q square root of 5 linear combination of 1 and root 11, and it equals 0, then the coefficients must be 0. All right, well, let's see how to use that. Well, in part A, we showed that every element of Q adjoin root 5 root 11 could be written as A plus B root 5 plus C root 11 plus D root 55, where A, B, C, and D were rational. Which means a basis should look like 1 root 5 root 11 root 55. That's what we hope, right? Well, we know it spans, right? So we already know spans was part A. So we again just need to show it's linearly independent. So let's assume that you had A, B, C, and D, rational numbers, such that A times 1, which is A, plus B root 5, plus C root 11, plus D root, well, instead of writing root 55, let me just write root 5 root 11. Assume that that equaled 0. All right, so we're going to factor, and we have A plus B root 5, I'll put some parentheses, plus C plus D root 5 times root 11, and that still equals 0. Okay, but A plus B root 5 is in Q root 5, as is C plus D root 5. And so I have a Q root 5 linear combination of 1 and the square root of 11. All right, but just above we said 1 square root of 11 is linearly independent over Q root 5. So if I have such a linear combination, the coefficients have to be 0. So A plus B root 5 has to be 0, and C plus D root 5 has to be 0. Okay, but we also know that 1 root 5 is a Q basis for Q adjoin the square root of 5. Well, that means if we have a linear combination of 1 and root 5 and it equals 0, then the coefficients have to be 0. Well, that's exactly what we have up here. So we know that A and B and C and D all have to be 0. Okay, but that's enough to show us that our original list, 1 root 5 root